Welcome everyone, and thank you for attending today's webcast, Autodesk Inventor, the Power of Parameters and iProperties. Our presenter today is Kindred Cooper. He's a solutions engineer with Hagerman & Company. Before we get started, I'll let you know that you're in listening only mode. If you have questions during the presentation, you can enter those into the question panel on the right-hand side of your screen. And they'll be addressed at the end of the presentation. As we close down the session today, you'll be prompted to fill out a survey, and we do ask that you take a few moments to fill that out for us. And additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. With that, I'll hand things over to Kindred.
Thank you, Ashley. Greetings, everyone. Welcome to today's presentation. Again, my name is Kindred Cooper. I am a solutions engineer with Hagerman & Company. And backing me up today running the Q&A panel, I have Keith Dorn. He's a solutions engineer with Hagerman & Company out of our Indianapolis office, and I am out of Knoxville, Tennessee. So with that, we'll jump right into it. This slide obviously is for anyone who's having difficulty hearing me, but it's also a good slide to show you the questions and answer panel. We are going to have designated time at the end to address any kind of questions that come in. But feel free to input questions as we go along. Something may come up and trigger you to make you think of a particular topic or workflow issue, and you have a question, by all means put it in there. So let's get right into it. The whole purpose of all of this is over the past many years, we get a lot of questions through our support line, through consulting with companies, through conducting training classes, and even seasoned Inventor users will sometimes either forget or not know about some of these topics we're going to discuss and some of the workflows. So I wanted to take all of us back to a basics level to start at the beginning and show some of the fundamentals that can help reduce your errors, reduce your cost, and reduce your time spent on documenting your design. And that comes into the form of parameters and iProperties. So where does that information play into your engineering field, your engineering scope? And the parameters and iProperties, while they are not always a key component in the concept phase of a design, once you start creating that design, documenting that design, fine-tuning materials and operating specs and parameters like that, then they become more critical. But in the initial concept, probably not. And even though dimensions are critical in the design, so is that metadata, that information, that iProperty information. And the parameters of your model and of your sketch can be reused in those dimensions and in that metadata. So when you look at something like an engineering bill of materials, all of this is going to kind of circle around that bill of material because it can all be incorporated into that bill. And that bill is just one piece of that puzzle. It's just as important as any dimensions or operating specs of your design. There's additional information that is put into a bill or can be put into a bill of material that can possibly make it more critical than some of the dimensions and operating specs. Typically, your bills of material might be managed by some type of ERP system, very similar like SAP systems or Oracle, or even some of the smaller systems like JobBoss can even manage and produce your bill of material for your entire organization. Not all engineering departments actually incorporate with that. They kind of let production handle the bill of material sometimes, and sometimes it's driven by engineering. It's kind of a mix out there. More recently, in the past, I'll say 5 to 10 years, the CAD file has become more integral in all of that process to bring that information out of engineering and start pushing it into other fields and other departments. And I'm not talking about just design information. I'm talking about the parameter information and the property information, not only just materials, but maybe even things like alternate vendors where you're going to buy something from, or alternate machine shops that's going to make it for you, like tier 1, tier 2, and tier 3 suppliers for you. Where can that metadata be, and where can it push out to, and what can it influence? At a corporate level, everybody can look at some piece of that bill of material. And in the concept phase, again, a bill of material may not even come to mind. You just have a basic idea of what you're going to make, basic operating specs of it, what it's going to be used for. That might be about it. You don't necessarily have an idea of, okay, well, who are we going to get this piece from? What is that piece going to be made out of? What's the operating limitations of that piece? And how big is that piece going to be? Those things come in the design phase. But a bill of material can start to form and exist in that concept phase. You'll know you'll need a certain number of pieces. You'll know it has a basic operating scope and a basic use. So that's starting the bill of material. Once you get in the design phase, then more and more pieces go into that bill of material. Obviously, when purchasing comes into it, they can have a very critical role because maybe you're using some new materials that they don't have on their books. So they're going to have to go find a supplier first, get those materials in, and see if those materials even meet spec. That's where QC comes in a lot of times. Testing the materials, testing the design, the formation, even purchasing, testing the supply chain. Are we going to be able to get that material in fast enough to meet our demands? So everybody starts getting their hands in a bill of material in some fashion in a corporate level. And then when production comes into it, they have to follow that. That's their roadmap to make that design. So your bill is not solely driven by the design team. QC has an input. Purchasing has an input. Production can even turn around and back up and say, hey, wait a minute, y'all got this organized as a subassembly. That's not going to work based on our setup. We need to restructure this a little bit. So there can even be pushback in that direction. The bill is pulled by other areas, consumed by other areas, and not solely driven by your CAD design. Again, purchasing and QC pushing back. So looking at the basics of this, the first stepping stone, that's where the inventor parameters come in. The term parametric modeling actually stems from those inventor parameters. Every numerical value you put into your sketch or into your feature, whether it be a linear sketch dimension, an angular dimension, a radius or a diameter, an extrusion length, a revolution angle, or even a pattern field, pattern quantity. All of those numerical values become parameters that you can push and change and reuse, and the reuse is where the properties come into play. So there's a nice domino effect of how all this kind of changes together, and we're going to look at all that. In the end, you get to a drawing, and this is where, on our side of the fence, this is where we see the biggest cost impact and biggest time impact. Far too many times I've seen customer after customer get to a drawing, place a parts list on the drawing, edit the parts list, and immediately start typing in the part numbers, the descriptions, the materials, project association, all of these different fields of information related to that piece part or that line item in a parts list. That is a ton of time, especially if pieces out of that design are reused in other designs. So now you're not just having to manually key in the information, you're manually keying it in multiple places. You've just increased your risk of duplicating the wrong information or even typographical errors. All of that's going to cost you time to either go back and fix, or they don't catch it until it gets out into the production line, and by then the costs have surmounted hugely. So static input of a parts list, you go in there and you start edit it, converts that information from an automatic update or a real-time update into a static list. Again, cost is a big factor when you do that. So looking at a static parts list versus a real-time parts list. Static at the top, real-time down at the bottom. With a real-time, any design changes made on the information of the piece part or on the assembly or even quantity in the assembly, those changes are automatically pushed into that parts list. You don't have to touch it. It's just automatically updating. That goes for part number, description, quantity, project, subject, any kind of field you can think of. The benefit of doing this is obviously there's no duplication. You're going to type in the information once in one location, and it's going to push down the line. You're also going to reduce your errors. If you mistype it here or you put in the wrong quantity, maybe you've shortchanged them on how many bolts they need because you think in your mind or the way you counted it, they need 20. Well, they actually needed 24. So you can have little issues like that crop up. So looking a little bit closer at just a static parts list, again, this is in a drawing. When you pull up that parts list and just start making changes to the fields, they may already have information in there. In the material column, notorious place to talk about, a lot of new parts in Inventor are assigned a generic material. There's no specific material association built to it. So you'll come in here and look at the material column and it'll just be filled up with generic, 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 and people will start going in there and typing that out and changing that. Also, another component plays into this. A lot of people either don't have the time or don't know how to interface with the Inventor material library to make changes to that and add their custom materials. That plays into this also. And all of this is kind of connecting together. We're going to be starting a new mini-series in our newsletter where we're getting back to the basics of things, where we're talking about the foundation stones to lay down to reduce your time and reduce your errors and reduce your cost. And it's going to be a series of, actually mini-series of tech tip videos going through each topic, and this is an example of one of them. So now the question comes in, okay, you got the parameters, they can feed into the property information, you're going to populate the property information at the part level so that it updates the parts list on the drawing. Okay, what's the difference between using the iProperties in Inventor versus the Windows properties, the Windows file properties? So any file that exists in Windows has a series of properties associated with it. You can see the screenshot on the left. A general tab has some basic general information. You have a security tab, custom tab, details tab, pretty basic stuff. It's geared towards office type documents and media type pieces of information. When you switch gears and go over and look at the iProperties for Inventor, you have unique pieces of information that are for engineering type designs. They're actually dedicated for CAD designs and CAD documents and drawings. So you have things like a part number and a stock number that Windows properties do not have. You have a description, sure, that might exist somewhere in the Windows properties. Revision number, no, that's not going to be there. Project, maybe hit or miss. Designer and engineer, most likely not. So you got these unique CAD-related, engineering-related property fields. You also have things like a status tab for if it's a work in progress, pending release, or approved. And you have a custom for anything that doesn't exist already. And the custom is a good stopping point for things like preferred vendor A, preferred vendor B, minimum coating thickness, things like that, certain operating specs that you may want the part to conform to. Now let's go a little bit further and bring in Autodesk Vault or some kind of data management package. That could even be Adept or Blue Cello, or there's multiple data management packages out there, but we're going to be talking about Autodesk Vault. So when you're starting in engineering, about the 1 o'clock position on this wheel, that's where everything kind of starts to feed in and build and grow and then go around the wheel. Quality is going to feed back into it. The shop floor is going to feed back into it. Production planning is going to get in there, purchasing and marketing and even sales. So how can Vault, which has traditionally been kind of an engineering-only tool, that's how a lot of people see it, how can it come into this whole wheel full circle and help everybody out? And how does all this information relate into that and help all these other departments? With Vault and with some of the higher flavors of Vault, such as workgroup or professional, we're able to go outside of engineering and bring in other departments. So that gives every department access to this information. So everybody can go in there and look at the drawing, look at the bill of material. Everybody can have read-only access so that they can't change anything. They go in there and just view it, and they can run searches to look for certain parts and certain related parts and what assembly uses what parts and what pieces might be purchased, things like that. With Vault, especially when you go into the higher flavors, you get other possibilities that come into play. The only thing we're talking about right now is just the properties down here in the lower left. But there's other things that go into Vault that you can utilize. You don't have to, but they're there if you need them. Things like folders and categories and life cycles and user groups and roles to allow certain people to make changes and certain people to make certain types of changes, and then to lock other people out and keep them from changing it and grant other people read-only access. Vault has all of that capability along with reporting. So you can take a snapshot of a design folder and say, okay, here's what's being worked on, here's what's been approved, here's what's coming from purchasing. It gives you a nice graphical interface, graphical report of where things are in your design process. Vault, just like Adept, just like Bluecello, it's not solely for, first off, not solely for Autodesk files. You'll see in the graphic on the left, there are other file types built in there that we can handle. ASM files, neutral files from ProE and Granite, SolidWorks files, CATIA files. We can incorporate all of those files and manage those in Vault without any issue. But looking on the right, you can also see it's not just CAD files. You've got JPEGs, you've got videos, you've got Word documents, emails, anything you want to add to Vault, it's going to handle, and you can interlink all this information, again, giving everybody kind of a full access to the full picture thing. Vault goes outside of engineering to bring that capability. So enough of this. Let's get down to it. Starting with the basics. Okay, I'm looking at a basic sketch and thinking in mind of some structural steel tubing, tube stock, square tube stock. Looking at the details of the sketch itself, standard run-of-the-mill dimensions, 2 by 2, 3/16 wall, and basically 5/16 radius on the corners. When I change the dimension display, right now I'm looking at the default tolerance method of viewing dimensions. If I change and I look at the expression method, you'll see each dimension has a dimension value. D0 is actually the name of this top dimension, and it equals 2 inches. The same thing goes for dimension 1 and 2 and 3. So every numerical value you plug in here gets a dimension name associated with it automatically. This is happening in the background. If I change this to just look at the values, of course values aren't very helpful looking at it in this form. You need it to be something a little bit more meaningful. All of this is stored in your part model and your assembly model in the parameter manager. Typically located on your manage ribbon, there's a parameters icon. There's also an icon in your quick access toolbar. When you launch the parameters manager, you'll see all the parameters, all of the dimensions you've put into this up to this point. And the generic names are associated over here at the left. The equation, you can plug in the value. You can even plug in actual equations, multiplication and division, addition, subtraction, into the equation and let Inventor do the math on that. But we're looking mainly at things like the model parameter names. We need these to be something more descriptive and more meaningful. So on the parameters, we can rename those. So I'll just call this one width. That's the top 2 inches back here in the back. The vertical 2 inches down the right-hand side, I'll call that one the height. And this one is actually the corner radius. So a little takeaway from this, you'll notice I'm using caps on some of my letter cases, and you'll notice I'm using an underscore. In the parameters manager, you're not able to have spaces and special characters. It limits you. I'm using caps because that's kind of my habit. You don't have to, but you have to put in an underscore if you want any kind of letter separation. It will not allow spaces. So looking at the next one, D3, that's going to be my wall thickness. All I've done is rename them. Nothing special yet, just change the names of them so when I come back in here and I look at the expression, it's now much more meaningful. The width of this bar stock is 2 inches, the height is 2 inches, so on and so forth. So let's get out of the sketch and let's go ahead and extrude this into a 6-inch piece of stock that we're going to use. So when I use the extrude command, comes up and there's my 1 inch that it's going to extrude, and I'll go ahead and say 6 inches on that profile, make it asymmetric. And whether it's 6 inches, 2 feet, 3 feet, whatever you plug in your value, this is going to create another dimension in that parameter. It'll be D4, dimension 4. There's also going to be a dimension 5 created. Even though you don't see it here, that dimension 5 is going to be the taper angle of the extrusion. Well, I'm not using a taper angle. I'm just taking a 0 angle taper. Well, 0 is still a value, so it's automatically going to create that for you. Instead of having to go in the parameter manager every time after you create something, you can rename parameters on the fly. So again, getting back to basics, in the extrude command, I'm going to call this my tube underscore length. That's going to be the name, and then I'll just use the equal sign and specify that length, and I'll just say 6 inches. When I say OK, makes the extrusion. If I go back and look at my parameter manager, you'll notice right here, there's my tube length. Value is, or equation is 6 inches. There's the D5, the actual taper of that extrusion. I can rename that if I want to. I don't have to. It's personal preference or whatever your process deems necessary in this case. So, great. So I've named these. Where's that going to benefit me? Well, looking at it from a very basic standpoint, when you incorporate something like the iProperties into this, when I look at the iProperties of this file, again, you've got a general tab that gives some basic information. You've got a summary tab, title, subject, things of that nature. These are more in line with generic Windows properties. When we go to the project tab and the status tab, that's where the CAD unique or engineering unique property fields come into play. So looking at things like part number, by default that's set to mimic your file name. You can change that here. Stock number, description. Let's look at description. Okay, so we're going to be putting this into an assembly, and we're going to be making a drawing of it. So we want to have a description associated back to this part. Otherwise, we're going to have to manually input this information down the road, and we may not be consistent across the board when we manually input that. So let's make it very consistent. I want the description to say the size of this tube. So I can say 2 inch by 2 inch by 3/16 wall tube. We'll say square tube. Square tube. Okay. That's a good stepping stone, at least from now going forward. In every assembly and every drawing that this piece of tube stock exists, it's going to have that description. And I could even go a little bit further and say by 6 inches long square tube. So that pulls all the values. Here's where this can break down. If I come back into my sketch and I change my width to say a 2.5, and I'll change my height to say 1.5. When I finish the sketch, obviously the solid updates. When I go look at the iProperties project tab description, now we have a problem. The description doesn't match the configuration of the properties of the sketch and of the part itself. So we want to link this information back to the parameters. Here's how you do that. In the parameter manager, any of these pieces of information that you want to reuse, whether you reuse them here or in an assembly or in a drawing, any of them you want to reuse, it's always good practice to go ahead and give them a unique name. Second step is to come over here and check the export column so that you can reuse these pieces of information. Actually, I'm not going to use the corner radius. I'm not going to worry about that one. So once you have them named and you've chosen the column to export them, over here in the parameters, we have to set up that relationship. Again, this gets back to basics. So what we're going to do is we're going to wipe this out. And on the description field, we're going to type the equal key, and we're going to use the caret, the greater than, less than symbols. Your parameter names, in order to be referenced in a property field, you have to enclose them in caret. So here's what that means. I'm setting up an equation or a relationship right now using the equal sign. And then I'll use the less than caret, and I'll type in my parameter name. The catch with this is you have to type it in exactly. So if you have capital letters and underscores in your parameter name, you've got to put them in here that way as well. I can't do a lowercase w for width. I actually used an uppercase W, so I have to recreate that here. So with uppercase W, label or call out the name of the parameter width, and I close it with the greater than caret. So equals caret width caret. Then I'm going to say space, the letter X for the by symbol, another space, another caret, the parameter for height, then spell out my wall thickness, then finally my tube length, and then after that I can type in whatever static description I want to put in. So we'll say long square tube. Now once I have completed that equation and I press enter, you'll notice out to the right of that property or that field, you'll see a function X icon, which happens to match the parameter icon for the parameter manager. This lets you know that there is an equation driving that field of information. If you need to change this field, now that it's got an equation in it, if you need to change this field, you have to click that button. If you don't, then you're wiping out your equation. You're kind of blanking it out and breaking the link. So you hit the FX command here at the property field, and it takes you back into the equation. Make whatever changes you need. And you'll notice it's calling out the information. 2.5, too many zeros, by 1.5, too many zeros, by wrong format for the wall thickness, and 6 inches, too many zeros, long square tube. I said all that because that's stuff we're going to change. Don't want you to get the impression that this is just how you get it and that's it. So we're going to go into this a little bit further. Come back into your parameters manager and you can set up custom formats for each one of these. So let's look at the width and height and the wall thickness, for example. You can right click on the equation field, custom property format, and you can choose how this parameter is shown in that description field. So we're going to keep it as decimal. Actually, we're going to change it to fractional. We're going to change all of these as fractional. What that's going to do is it's going to turn off any kind of leading and trailing zeros. We can set the precision of it. 1/8 inch is fine for this one. We'll do the same thing on the 1.5 inches. Set it to fractional. Just so you know, we can also change the units of it from inches to something else. We're going to do that on the wall thickness as well. Oops, wrong click. So I'll change that to fractional, and I'm going to tweak down the precision from 1/8 to 1/16 so it picks up that 3/16. And then the last thing is on the tube length, doing the same thing, changing it to a fractional. With that simple little change, I'm back to my parameter or my iProperties, and you'll notice the description has changed to be the 2.5 fractional, 1.5 fractional, 3/16. That's getting my description for this part and a drawing of this part being used in an assembly, and the assembly bill of material calling out that description, which is ultimately going to be placed on a drawing parts list. This is where you're going to save your time and reduce your errors. If you have to type this in multiple parts lists, 20, 30, 40 different designs, you may type it in exactly like that every time. You may key in something wrong. You may misspell a few words here or there. Little things like that can ultimately cause problems sometimes. If you type in the wrong length or height, they could order the wrong material, for example. So all of these property fields can be set up in this nature. Stock number and part number can pull up information. Project can pull up information from the parameters if you wish it to. You can set up all of that information. Then once you get into an assembly, all of that stuff automatically populates. One additional little thing I wanted to show you with parameters is incorporating tolerances. So for example, back in the sketch, looking at something like the width, okay, might be a bad example, but it's the one we got. I'll right click on that dimension and I'll go to dimension properties. You don't normally put a tolerance on something like this, but we'll run with it. Looking at the tolerance type, I'm going to set up a symmetric tolerance, and I'm going to put in plus or minus 10 thou on this. Okay, so, well, actually, it may not have taken. Okay, it did. And I'm going to, currently it's evaluated to the nominal size. I'll change my display to show the tolerance value. So you can see 2.5 inches plus or minus 10 thousandths. Finish my sketch. Go ahead and save my part. Now, where that plays in, if I take a measurement, just using the basic graphical measuring tools, it comes up and shows me 2.5 inches for this. If I go back to my parameters manager, I can set the evaluation for every one of these dimensions. And if a dimension has a tolerance on it, like the top one, the width, I can set that to evaluate it either to nominal, minimum, maximum, or mean, or the average. So I'm going to set it to evaluate it to the minimum tolerance. Now, when I do that, it should take 10 thousandths off of it. So now when I take a measurement, you'll notice it's measuring at 2.49. Okay, great. So that way you can kind of adjust your design to reflect the tolerances in case you need to look at a limits and fit situation or stack up situation. You've got a bunch of parts going together, and what happens if they're all made to max or all made to min or vice versa, a mixture? What happens to that stack up? Does it still fit together like it should? So the model is actually going to reflect that not only in the piece part, but also in the assembly and also in the drawing. So what happens to our iProperties in this situation? They are being updated as well. Once I run the update through it, they'll come in here, and if I change the precision or change the format of this, since it's evaluating to fractional, it's not going to show that precision. But if I change it back to decimal, you'll see that 2.49 inches show up here. So the parameters can push all the way in to that iProperty field, and the evaluation of the parameter can also push into that, which ultimately leads into the bill of material in the assembly and on the drawing. So let's look at that whole scheme of it. Looking at a basic assembly of a product, a bench vise, for example, got a parts list up here, and if I just double click on that parts list, there's a lot of blue fields in here. Somebody has came in here and manually typed in part numbers and descriptions, and that's a lot of time. That's a lot of time to key in that information. So by doing so, case in point, if I just take this ductile iron material and I back out the word casting and I press enter, that makes it a static field. By doing that, any changes made to the piece part are no longer updated in here. The only time I would recommend any kind of static override is on a quantity, and if you envision going to a retail store and buying a home computer desk or an entertainment center or something like that, and you get it home and start putting it together, they always give you a little bag of extra fasteners in case you lose one, in case the dog eats one, in case the cat takes one to play with, whatever. You get a little extra bag of fasteners. That's the only time I would foresee a need to actually set up a static override in the parts list. Give them a little bit of a pad. Give them a couple of extra screws or washers or things like that. That's easily done. Change the quantity from, whatever is being calculated from 4 to maybe 6. Okay, fine. That doesn't take that much time, doesn't eat up that much cost. But doing it on the entire parts list, that's a lot of work. So it's actually best if all of these fields are not set to static. The way you do that is you select the field. I've highlighted all of them, by the way. But you basically select the field that is static, if it already is, and you uncheck that static value. That resets it back to compute it from the assembly and from the piece part iProperties. So I'll just go ahead and set the whole table to function that way. Now they're all recomputing from the model. So if the piece part changes or the quantity changes in the assembly, it's going to automatically reflect here. So where can all of that information be pulled from? Okay, the iProperty information that we were looking at on the piece part a minute ago, the description, the material, the project, all of that is coming from that information. Of course, you can customize your parts list to display whatever columns you want. The same can be said in the assembly bill of material. So we're talking two different types of objects in Inventor, just because of how they've termed these objects in Inventor. They're referring to this chart as a parts list. In the assembly environment, they're referring to a similar chart as a bill of material. There are some subtle differences in how they both behave and react. Looking at the assembly bill, you have a structure tab and you have a parts only tab. You may have to enable these to see the context of them, but the structure tab gives you that sub-assembly structure if you have any sub-assemblies built into your design. So you can drill down into it to see the item number and the sub-items underneath it. Item numbers, by the way, are governed by the assembly as you place components in that assembly. You can change these item numbers. There's no rule or property or anything like that that's currently controlling them. You can just override them to whatever you want them to be. If you want a part to have a particular item number regardless of the assembly it goes into, you can do that as well. You can make a custom iProperty on the part and map that into the assembly bill of material easily enough. So all of this information is pulling directly from the piece parts. Now, a handy little feature is if you forget a piece of information or you put in the wrong piece of information, take for example this guy here, top piece. We've got it currently set for steel, high strength, low alloy. Maybe they come back to me and say, no, we're not going to make it out of that. We're going to make it out of a different material. The beauty about using Inventor is from the assembly bill of material, you can change this information and push it back to the part. From a drawing parts list, you cannot. There's a very key difference there. So the drawing parts list, if I edit it, there's no way I can push any of this information back to the piece part. It's just changing it here in the table. Whereas in the assembly bill, for example, if I change this guy from high strength steel maybe to a different alloy, we'll just come in and we'll check that out of Vault. I'll check out that piece part that I'm working with. So now I can change that field to say maybe a carbon steel or even a stainless steel, whatever you need to put in. So once I make that change, that's not quite enough yet. I've made the change in the bill. When I hit done and I click on save, notice what happens. Notice in the save prompt, do you want to save that assembly? Yeah, I want to save that assembly. Do you also want to change or save that piece part? That's the one where I made the changes to in the material. That's going to happen with every piece of information in this bill. As you change it here, it's going to push it all back. So if you want to, you can wait until you get to the assembly phase, get your bill of material generated, and start making your changes and push everything back to your piece part. It's a nice one-stop shop, one window to kind of look at everything and change everything at that time. Another key example where all this can come into play is hardware components, fasteners, things you pull out of the content center. The content center items are already pre-populated with lots of pieces of information, but there may be other things you want to add to those, and you can do that on the custom tab. Again, such as preferred vendor A, preferred vendor B, so on and so forth. Those same pieces of information can be added to those components and incorporated into your design, either into your assembly bill of material or into your drawing parts list to give production and purchasing an alternate buyout, an alternate place to get these pieces from. So how does all this incorporate into Vault? Well, it incorporates very smoothly, actually. Once you add your designs, your parts, assemblies, drawing everything into Vault, there is a properties panel that you can display, and it's got some system property information that it has. These are Vault related system fields, property fields, but then down at the bottom you have a user defined. So actually I'm just going to minimize system to show you have a user defined section of these properties to give you that information that you put in on your piece part. So right now I'm just looking at a piece part. You can look at any of these piece parts. If you jump to a drawing or an assembly, it depends on what pieces of information you have put in there. So on my drawing, I haven't populated anything yet. From within Vault, you can edit those properties here if you want to, and it'll push that information back into the CAD file. The other benefit for using Vault in this situation is, okay, not only can you look at a design, for example, and we can look at this assembly and say, well, what does it use? Well, it uses all of these pieces. Well, right here is a hardware component. It's a hardware fastener of some sort. Where is that used? How many designs is that used in? So if we change this out or make a change to it, how many things is it going to affect? Or if we replace it, like if we change the material? The beauty of Vault is you can look at that component file and you can look at where is it used. So when I go to where used, you'll see all of the assemblies and drawings impacted by any changes to that piece part. So there's where that domino effect comes in of the parameters being used in the sketch can be referenced in the description. In the description, that can be referenced into the assembly bill of material and the drawing parts list. You check that information into Vault, we can search on that information. So if I go into the find utility, I can search on any file property for any file that comes into Vault. And notice I said any file. I didn't say any CAD file. Literally any file that exists in Vault that has property information. And you can perform combo searches. So I can say, well, let's look at every file that has a material that is not empty. The material field is not empty because, let's face it, we might forget and specify material for something. So I add that to my criteria and run my search, and it gives me a list of everything it found. So right now we've got 16 files in this very small Vault that are affected by that. Okay, well, let's also build a combo search of, on that material, how many of them have a keywords that does not contain, or actually that contains, hardware. So now I get down to 5. So now I'm looking at my purchased or my hardware components, and I can see my various materials, print this out, give it to purchasing. Hey, do we have these materials available from our vendors? So it gives them a nice static snapshot, or purchasing can run that search themselves if they have the Vault client. So again, we just wanted to get back to a basics level of some of the workflow that maybe you knew it was there, but you weren't sure how it connected, or maybe you didn't know it was there. You weren't sure how to even get started on it. So we wanted to break this back down to a basics level and get you a stepping stone to where you can start putting this information in and save yourself some time on documenting your designs, documenting your parts, your assemblies, and pushing that information into other departments and letting them view it as well. So at this time, we'll go ahead and open it up to any questions that may be unanswered. Keith, how's our questions panel looking?
Pretty good. There's a couple questions. The first one was, if you use the copy design tool on a part with parameter data defined that way, what's the behavior of the copy? So in your case, you've got your bar stock part.
The copy design tool inside of Vault, is that what they're referring to?
I believe so.
Okay. The copy design tool does incorporate to work with those properties. It does have a nice checkbox, so to speak. If you want to update the part number field, sometimes the file name and the part number field don't always match depending on your corporate structure. So you can choose to update that part number field if you deem it necessary, but it doesn't incorporate all of the property information or property fields. It's limited to that that scope to change the file name, the associations of what it's with, if it's working with certain assemblies or drawings, if it's being reused or copied, and then changing or updating the part number field. Anything after that, you would simply just edit the properties of the components to to the correct syntax of the property field, whatever it is you're making the change to.
And the next question was, if I've got bar stock templates that have parameter driven, that's using a similar method that you used in your demonstration, it drives the bill of materials raw material description a size. How would I go through creating a custom iProperty to make that type of data?
The custom iProperty works in the sense of as soon as you go to the iProperties custom tab, you add a new custom iProperty. That's probably something I should take just a quick second and show everybody. It can be a little bit misleading. When you're going to create a custom iProperty, you're going to specify the name. So for this one, we'll go ahead and say preferred coding and whatever type of information it is, if it's text value, date, whatever. And then the value of that, we'll just say it's a stainless coating. And then we add that to the listing. If you hit apply or OK, it doesn't add that custom property. But once it's in here, it's associated with that file. Now to get that, I didn't check it out, but to get that custom property to show up in the bill of material of the assembly or the parts list, you have to actually come in here and you have to create that custom property or map it, so to speak. So I would add a custom property and I would specify its name here. Again, the syntax has to be exact. Capital letters, underscores, things like that. Once you add it here, it'll show up in your bill of material list, and the same goes for the drawing parts list.
Gotcha. So one of the things that kind of goes along with this, at least that I've experienced, is, inside of the parameters dialog box, you can actually steal data and use it for material gains and things like that. And there's an example in here where a customer has, say a part that's 3/4 inches thick, and it's being machined from an inch stock material. And so what I've done in the past is created custom parameters and then use the math within that system to define the next upsize, essentially. So like running a floor function.
Yeah, we have a lot of customers that will use that to, if they have a machine component, instead of having a rough cut drawing print, they'll just say, here's my machine dimension, my overall. I need a bar stock that is that value plus whatever machining tolerance you want. If it's a 1/4 inch, 1/2 inch, whatever, and they'll add that to the overall length and just route it up to the next incremental stock. We have some customers, this is incredibly impressive. It takes a little bit of setup on the front end, but the amount of time it saves you in the long run is phenomenal. We have some customers in the molding and casting industry that will have one custom user parameter. I'm talking parameters, not iProperties. That parameter will be shrink. So if you're making, if you're pouring an iron casting or a brass casting, it has a certain shrink rate. Every dimension they put into their design will be linked to that shrink rate times whatever the dimension is supposed to be. So if their shrink rate is 1/10 of an inch per foot, then it's going to be 1.08333 blah, 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 times whatever value their casting is supposed to be long. What that does is it automatically scales everything accordingly based on that shrink rate. So they automatically get an as-cast design of their assembly. And very quickly, when they want the machined or the shrunken, they can have a drawing for the mold. And when they want a drawing or a model of the actual cast, they just take that shrink rate out and set it back to 1, take out the actual multiplying factor. We have a handful of customers doing that. The sky's the limit, really, on what you can do with parameters and iProperty interlinking. There's also a method to set up multi-value to where you can pull down your parameters and pick from a list of parameters. That's one of the things we're going to showcase in our Tech Tip series, is how to set up these parameters with all the different functions of either interlinking them, building equations into them, pulling up a multi-value list, or a custom input. We'll set all that up in our Tech Tip series in our upcoming newsletters.
And then the last piece of this would be, you know, with that bar stock that you created, what would be the usage for, or what would be your recommended usage for that component if I wanted to use that part to, say, make an 8, a 10, a 12-inch version of it?
What I would probably do in that situation is I would create an I part of it, and depending on your setup and your workflow, I would quite possibly add that I part to a custom content center library for everybody to pull from. There's pros and cons with using just I parts or just using content center parts. Either way is going to work. You just got to figure out if the cons are going to bite you bad enough of each one of them. But once I get into, me personally, once I get into a size change, a size configuration that's more than half a dozen configurations, I look at making an I part and immediately putting in the content center, because you can customize your part number, stock number, description, everything in either an I part or in the content center. And I personally have found managing it through the content center is an easier workflow for me. Again, this is going to change based on organization and structure.
Absolutely.
Any others?
Other than those questions, I think that's it. Unless anyone else has any additional questions they'd like to ask.
Well, thank you everyone for joining today. I hope it was a good webinar for you. I hope you got a lot of good information out of it. Again, keep your eyes open for our next newsletter. We're going to start incorporating some mini-series and tech tip videos into this. Won't be a lot of reading material in these videos. It's going to be purely video and audio that will walk you through some of these basics and expand a little bit more on some of what you saw today and other topics that kind of pull us from the basics. We're going to stay online for another minute or two, answering any future questions that come in, but I hope everybody enjoyed it and got some good information out of it, and thank you for attending.
Approximately how long does it take before the recordings become available?
I will have those posted later today on our YouTube site, and then I will, everyone will receive an email probably tomorrow with a link to the recording as well. Also, I'll just let everyone know that if you think of additional questions later, please feel free to email us at events@hagerman.com, and we can get those to Kindred or Keith or whoever needs to have them to answer your questions. And once again, if you could take a few moments to fill out that survey, we would appreciate it. I don't see anything else popping in, so I think I'm going to close down today, but thanks, Kindred, for the great presentation, and have a great day, everybody.